This video will introduce the ArcMap extension Spatial Analyst and provide a few examples of the things you can do with it. Now, for those of you who are watching this video, there is an assumption that you've already been messing around with ArcMap, that you've already become familiar with it to the point where if you had to solve a problem, you would know how to pull in the data and also some of the basic geoprocessing operations that you'd most likely employ towards finding a solution. And remember now, spatial analysis deals with data reduction. You're trying to take a lot of data and using the parameters of what it is that you're looking at geographically, you're going to reduce the possibilities to where you finally get that which is what you want. Well, again, clips, merge, dissolve, things like that. Hopefully these are familiar terms to you. So now, Spatial Analyst. Spatial Analyst is going to do similar things, except instead of it being in the feature data world, points, lines, and polygons, it's going to gravitate towards the raster world, the cell-based world of GIS modeling. And what it's going to do is it's going to open up a whole new world of analysis, but also the kinds of data generated using raster modeling is just really going to just be very, very exciting. Now, what kind of things can you do with Spatial Analyst? Oh, and before we even go down that road, I'm saying Spatial Analyst, Spatial Analyst, Spatial Analyst, and then I've already said Spatial Analysis. Please don't confuse the two. Spatial Analyst, which you see right there at the very top there, the heading, that is the software. Spatial Analysis is studying the relationships between objects or locations in space. It could be for feature data, points, line, polygons. It can be for raster. So that is a more general term. So now, back to what you can do. Finding suitable locations. This is something that a lot of people are looking for in Spatial Analyst. Now, suitable locations can be everything from trying to find areas where you want to put new real estate to finding areas where potentially there is worry and concern over the hazards that maybe a location has regarding human communities, or maybe it's locating new schools and things like that. There are just let your imagination run wild when it comes to finding suitable locations. But this time you're going to take the data and you're going to put it into this raster world, and you're going to start looking at the values of the cells, and that's pretty interesting stuff. So what else can you do with this? Well, when it came to ArcMap, when it came to doing distance analysis, okay, that's one of the workhorses of ArcMap, doing distance analysis. But this time now we're going to start creating these surfaces, these raster-based, these cell-based surfaces that represent distance. Now, the one over to the left, okay, here's a camping scenario. Here's campsite A and here's campsite number B. And you'll see that using these this sort of zonal-looking raster that you see over to the left, pretty much more straightforward types of distance is being represented here. And even though they did take the liberty of creating these zones of distance, but still, okay, you're looking at this kind of straight distances. And for any of you who have gone camping, you know that that is a fantasy. Okay, you will learn a very important lesson if you say, let's just draw a straight line between point A and point B, especially if you're up in the mountains. Get ready for a lot of pain and misery. Now, let's look at B. Now, using Spatial Analyst for cost of travel analysis, now we start seeing something that seems more like reality. Okay, if you're going to do a hike and you look at this this raster here, you're going to see that there are different values when it comes to the cost of travel walking around. And then when you look at that, you'll say, maybe we really ought to walk around that that mountain that's in front of us, or take this path, because even though it seems like it's longer, it's going to cost us less when it comes to wear and tear in our bodies. So this is a really good example of spatial analyst looking at distance. Now, looking at statistical analysis. Had a hard time getting that word out of my mouth. My guess is that everybody who's going to be watching this video has a certain comfort level when it comes to statistics, and there's nothing wrong if you say, well, I've never been too comfortable with statistics, or if you say, I've been messing around with this since I was 8 years old, and I have a total command of statistics. Okay, more power to you. I wish I was like you. But you're going to see there's a whole world of users when it comes to statistics. Spatial Analyst has some very basic but very effective spatial statistical analysis tools that allow you to do some really good things. At the same time, for those of you who are the more high-end statistical users, don't worry, those tools are there too. So you'll be able to have your fun also. Now, when it does statistics, it will do things like, for instance, look at the neighborhood of values of cells around a certain point. Let's say, for instance, if you're doing population studies, that a lot of human beings, we like to live in cities, and there's just a super concentration of people. But then you'll see that as you leave a city, it isn't a gradual reduction in population, at least in a lot of places. I'm not trying to be general for the whole planet, but still, there's if you understand what is happening on the landscape, you might start tweaking things based upon cell values around a certain location. So that's just a quick example. But the example here, you'll see that slope is in the upper left-hand side, so it's representing the amount of slope in an area, and down over to the lower left, you see watersheds. Now, you want to generalize, say for whatever study, you're going to do some planning, you're looking at, well, wherever to put a community or whatever. Over to the right, statistically, you can combine the two, and based upon the values of each one of those watersheds of the slope cells that were within it, you can get an average mean. And therefore, it just makes it a little bit easier for people to make decisions based upon that final result over to the right. Now, when it comes to generating data, in particular surface data that's been interpolated data, that's when you're mathematically, at least you should be doing it mathematically, identifying the most likely value of a phenomenon based upon what you know. Now, in this example here, you see the state of California, United States, over to the left, and all those points have some sort of value, whatever it may be, population, or it could be, say, an invasive species of some insect or whatever you're looking at, values of homes, who knows. But you don't have a point down in every place in California. So what do? You take known values and you plug them into Spatial Analyst, and what it does is it creates an interpolated surface to the right, and it is giving you its best idea of the distribution, the values of that certain phenomenon that you're trying to map. Now, this is not new to you. The reason being is that every day when you, however you gather this information, your weather data for the day, you're going to see that quite often they provide a temperature map of an area. Now, whether it be a country or a smaller area, world map, whatever, you don't have a weather station every 10 meters across the area. What you have is a series of stations that they're gathering the temperature for that day. And what the weather people do is they bring it all together and they interpolate temperatures as best as they can. So that map in the morning, I assume you watch your weather forecast in the morning. What you're going to see that though that weather, the temperature map, that temperature map is an interpolated surface. So you've been working with these already for a little while. Now moving forward with the creation of data, the manipulation of data, here's a term that I wish the industry would say goodbye to, but let me read this to you verbatim, okay? Clean up a variety of data for further analysis or display. Cleaning up, okay? It implies that the data was dirty. And that's not the case. A lot of times whenever you create your first data set, it may probably is the most honest data set you created. Why? Because, well, it hasn't been really manipulated. It shouldn't have been. And over to the left, let's just say that was, say there's an air photo or a satellite image of trees within a forest area, and through analysis, they determined the kinds of trees that you would find within the forest. And okay, that's what you have to the left. Now let's just say that a forestry service said, you know, we're about to do some planning when it comes to trees and whatever it is that they're looking at. It could be trying to combat some invasive species or whatever, or disease in the forest, whatever. But they need a more generalized map. Well, what you can do is you can take the values of the cells, and using statistical analysis, you can create a more generalized product. And so, well, to the right, everybody, it's clean, by golly. Now, when it comes to creating new data, also, you're going to be able to take a single data set, for instance, the elevation raster that you see over to the left, and you're going to be surprised on how much you can do with elevation data. With elevation data, in this example here, okay, deriving slope, deriving aspect, looking at the hillshade, you're going to be able to take a single data set and just break it out into a variety of things that are quite useful for analysis. Now, using those, the example of the 3 layers that were generated via the elevation data, here in this application right here, you'll see that, unfortunately, this is a study of an arson suspect, and you're looking at seeing whether or not the subject here would have been able to see the flames from where he made the 911 call. So this person, unfortunately, wanted to, well, get some notoriety for his action. And the question is this: would they be watching, actually seeing it? And so that would give the police clues on trying to figure out, who it was. So utilizing those other layers that were just mentioned, you can put it into a model that would allow you to answer that question. And unfortunately, I hate to say it, but one of the ways that you could really show effective use of GIS is when it comes to hazard management. Even though, of course, it saves lives, and that's a good thing. But GIS is a very effective tool when it comes to responding to the hazardous and bad situations on the landscape. So again, I guess that's a good thing, dealing with a seemingly bad situation. Now, when it comes to law enforcement, you'll be surprised really on just how well the law enforcement community has gravitated towards GIS. They're using it in a very effective way. Now, in this example here, prediction of intensity of drug traffic in a community, pulling in all variety of things, crime data, demographics, you name it, you're going to see that using raster analysis, it provides that additional dimension of how to compare data and to create surfaces that, in this example here, for instance, prediction of intensity of drug traffic, all those factors involved put together into a rather effective raster model. And I had the privilege of visiting a police department in the past few years where the GIS analyst, picture this now, we were looking at how they're predicting where crimes are going to take place. He was bringing in average temperatures, and he said, well, do you know that the temperatures of certain areas, there is a correlation between people going out and doing things? And I thought, gosh, I never thought about that. So yeah, they have a very interesting field of study.